Hi everyone, so my name is Matt, French, I can speak Spanish, Catalan a bit also. I'm going to talk about Kinto, which is the project I work on during the day for my work. And it's a JSON API that allows to store data, to synchronize and share the data on the web. So I'm gonna go through three main parts. The first one is like why did we start this project and what were our ideas behind it? How did we do it? And the last one is about the pyramid framework, because the two first parts are about the product, and since I'm not here to sell the product, and we are at the Python Meetup, so I thought it was worth it to talk about pyramid and how we use the concept of pyramid for the project and what we like about pyramid. So it's going to contrast a bit with the David presentation because pyramid is very different than Django. So it's going to be very complementary. So why Kinto? Kinto is a very simple idea. It's a storage API where you can put some JSON, store them, and you can see that as a web database. So it's basically a remote storage. When you push some data, you can use it to synchronize this data between different devices. So, for example, different mobile tablets, desktop and stuff. And contrary to the other existing solutions for that, it is meant to allow sharing of data. So, for example, you have your collection of pictures, and they're all private, they're all yours, but some of them are like public because you want to show the picture of the Python Meetup event, or you want to share them with your wedding friends and stuff. So that's one big difference, and it's also thought to be very minimalist and simple. So it's not rocket science. It's meant to be very simple, like the famous French car, la deux chevaux, which I don't know, dos caballos, where you can just open the engine and understand what's going on. It's very simple. Another ideal behind Kinto is also that your data is yours. I mean, it sounds stupid, but it's actually pretty hard to respect. Your data does not belong to the app developer, so the idea is to remove the coupling that there is between the application itself and the location where it stores the data. So, for example, you have a note-taking application. It's full JavaScript web, and it's a web app. But most of the web apps like that, you can see that they are coupled to the location where they store the data, which is usually the company cloud, and usually the company resells your data and makes statistics and and compromises your privacy. So the idea behind Kinto is to remove that coupling between the application itself and the location where it stores the data. It's meant also to be very easy to self-host, like you can deploy your own, or you can, as a group of, as an association or cooperative, you can have like a shared instance of Kinto. And then when you use that application, you say, okay, my Kinto is there, and when I use that application, the data goes there. So it's basically the idea behind it. So the location of your choice, because you have to be in control of what becomes your data. And of course, it's also thought to support encrypted data, because you don't know who's going to put a hand on your server. So the client encrypts the data, puts the JSON there, and when the next client comes and synchronizes the data, it's going to decrypt and get the thing. Of course, when you encrypt the data, you cannot ask the server to filter or sort by field because it's all opaque. It's one of the big features is synchronization. So you can obviously use it as a live storage API, where, as I said, you can put some data, set the permission to share it, and access it and edit it and stuff. Using some push notification features, you can have collaborative apps. So when I create or edit something, it pops up on the other screen or user or device or whatever. So it's very easy to do like collaborative apps. Offline first is the idea that you keep your application working when you don't have network access. So basically what we do is the client synchronizes the data locally. Then when there is no network, the application is gonna manipulate the local data. And then when you run a synchronization, it will take all the stuff that is being done locally, possibly handle the conflicts, but we don't do magics at conflicts handlings. This is the application developer that's going to be in charge of it. But yeah, we push the data, the new data, and your application is completely, for your application, it's completely transparent. I don't know if you've heard of that buzzword. I just wanted to put another buzzword after offline first. It's progressive web apps. The idea of that, behind that, is that you can have web apps made by HTML, JavaScript, CSS that behave and that look like a native apps. So you can have like home screen button, offline storage, and background services. If you have questions about that, we can talk about it. It's more front-end stuff. Like the API is very flat and stupid, and then you have cool stuff that you can do using JavaScript and web APIs. Don't try to do that in Python in the browser because you can't. Front-end stuff is in JavaScript. Universal also means reusable. What I mean with that is that you can have one API and several kinds of clients, several types of clients. One can be a shell script that puts some stuff in there. Another one can be a Android app, web page, whatever. It's universal. And because it's universal, it means you can reuse it for several needs. So you would capitalize your knowledge, your optimization, your deployment recipes, and your scaling jobs. You would do it once, and it's gonna work for every application that you have. So the idea is to do one universal solution, simple, and capitalize on it, and you can use it in many contexts. So that was also one of the idea behind it. And actually, that's what my employer pays me for, because every time there is a new idea, a new app, it costs money of engineering, and with that you reuse a lot of engineering. So before, when someone had a new idea, he was doing a front-end prototype, then he was going to go to the backend developer and say, hey, I need an API, and please deploy it, and then after some time, you could have something working. But with Kinto, you already have the API running, it's a black box, you implement your ID and you're done, because you don't have to worry about the backend stuff. So it really speeds up prototyping. Doesn't mean you will stay the whole project life with Kinto, but because since it's very generic, it obviously has some limitation depending on your domain specific stuff. But it's gonna really speed up prototyping, and you're gonna really, because with that you can go to some business angel and say, look, you have something working. Then use Kinto or not in the future, that's something else, but it's a very easy way to relax and stuff. Maybe that rings a bell. Some of you know Parse or Firebase. So Kinto is somehow presented as open source and self-hostable alternative to Parse and Firebase. This is funny because actually Kinto takes its roots long before those projects, but we could not do a proper product before getting paid to work on it. So that's the thing. Is there any question? I'm done with the whys, with why we did that. If there is anything unclear, I don't see it too much. So how did we do it? It's an HTTP API, as you would have guessed. It's done by a hierarchy of resources, and on each level of the hierarchy you have a set of permissions. So it's basically like a Unix file system where you have folders and you can put some permissions on levels, and then you can open the file and read the data. So you can store any JSON, like any field. You can put whatever you want. Every time you do an operation, there is like it's called a vector clock. Like every time there is a write operation, a timestamp is going to tick forward, and that serves us as a synchronization journal. So for polling for changes, you say, okay, my last revision number is that one, give me the changes since that revision, and you obtain a stream of changes. You can use the API to filter, sort, and paginate the data. You have cache and concurrency control, so that's very useful. For example, you say, I want to batch that record, so you do like in the REST world, you batch, you put, and you post. And you say, I'm patching this record, but the version I am based on had this revision. And if you do that with concurrency control headers, basically it's E tags. The server is going to say, no, you don't have the last version, you first have to resolve the conflicts. You can define a JSON schema to enforce the presence or the value of some fields. So it's a nice feature if you want to control what's going on. And in terms of API, we have all the good practices for versioning, deprecation. So you have a version prefix, so the old clients can still reach the old API when there is a new version. What we did is that we made everything pluggable from the settings. So we have a set of features, and you can substitute, plug, unplug every feature. And you do that from the settings files. You don't have to code anything. We do that through plain ini files, and they can be overridden through environment variables. So that's very useful for Docker and ops stuff. There are some built-in monitoring features. So as David said, they can allow you to know which part is taking some time. So you can enable monitoring and see that your storage backend, like your database, is taking a lot of time, or your authentication verification is slow and stuff like that. So we have built-in monitoring for each part of the application. And we have plugins to add some additional features that we don't want to have as the main ones. So the one we usually deploy is push notifications. So this is a very useful feature for live updates. Like the client is being notified when someone does something on the data, so you can refresh, resync. You can have, like as I said, collaborative web apps and stuff. File attachments. Since the API handles JSON, you could do you could encode your file as 64 bytes encoding, but you would have like those big JSON, and it's not very practical. So we have a plugin that allows you to attach some big files to some records. So when you synchronize a collection of records, you obtain a list of big files URLs. So it's a nice way to attach some records, but without having them in the JSON payloads. History of changes is very interesting. It's pretty new. It's not released yet. I think the pull request of the release is pending, but it was merged in master like last week. It's a plugin that allows you to track every user, every action on every object. So it allows you to obtain an history of changes for each record, collections of records, buckets, and stuff. Digital signature is also something that we did for the at work. Like, it was very important to have this feature. It's a way to make sure that the data that is being received by the client is the same as the data that is stored on the server. So using cryptography, you have signatures, and you make sure there is no man in the middle sending some fake data to your clients. And then, yeah, we have plugins for Firefox account authentication, LDAP, and a little bit, I wanted to give some details on how we store the records. So we use SQL Alchemy mainly for the engine stuff, the pool connection pools, transaction handlings. But for the records themselves, it's just like a big flat table with UUIDs and JSONB for the Postgres backend. We also have a Redis implementation and in-memory backend for development, for example. But for Postgres, it's a single table with JSONB. And we don't use the SQL Alchemy abstractions for SQL syntaxes, queries. We use the raw SQL queries like our parents. We have a per request transaction. It means if something wrong happens before the response is served to the client, everything is rolled back. So it's a way to have a transactional request, and it's done by Pyramid and Postgres. We have a very, very simplistic, minimalistic DB schema migration. So nothing to compare with, like, for example, Django migrations. It's just a very small hook to run custom SQL scripts on production when you want to migrate some data. So it's flat, so it's easy to shard, so it means it's easy to replicate horizontally. The permission backend relies on authentication, so you have two notions. One notion is authentication, which is like, who are you? And the other notion is authorization, which is like, what are you allowed to do? So we have pluggable authentication, which means you can identify API users using OpenID, GitHub, whatever, GitHub, LDAP, Firefox account. And then we have a permission backend that maps users and roles to say, okay, this user is allowed to write on that collection, is allowed to create record, or this user is allowed to read those records. So when he's gonna query the collection, he's gonna only see a subset of the records. So that's very useful. For example, if you have like your collection of I don't know. Imagine you have a gift wish list. Every time you have an idea of some gift you would like someone to do, you write it. Some of them are public, and some of them are like private. And when someone reaches your wish list, he's gonna only see the public ones, or the one that you guys shared with you, using the same endpoint. So the permission backend is a way to handling. Is in charge of handling the permission stuff. We have other like backends. It's like small abstractions. A key value cache with the TTL feature, so we basically use Redis for that. As I said, we have the file attachment plugin, which has file storage backend, which can be, it's also pluggable. It can be local file system or Amazon S3 and stuff. You decide. StatsD is for monitoring. So StatsD is a very efficient monitoring tool. So you basically have probes, and you say this feature is taking that much time. So then you have nice graphs of the execution time of your different parts of the product. And we also have a asynchronous task queue using Redis. I forgot to mention it was open source. It has. We are very happy with the contributors, and since it was featured on Hacker News, the number of stars went up. The number of contributors stayed low. And we try to do monthly community meetings. It means like if you have questions or if you want to do pair programming like remotely, we can do like a feature together or bug fix together. We have Docker images, and we are test freaks, so we always keep 100% of coverage, and the test fails if you go below. So it's like sometimes a bit extremist. It's fun. So it's an HTTP API. We made some clients. Like there is one in Python, which is basically an abstraction layer on top of awesome requests. So this stuff.
Yeah. You want the laser?
Yeah, I don't know, something. That's gonna close the curtain, right? Yeah. Ooh, never had this. So it's kind of hard, yeah. So basically, you instantiate the client. You say my server is there, and this is one example of method like get me the record of that bucket from in that collection. We have a JavaScript client also, which leverages promises and uses ES6, Babel, and stuff. I understood we actually not talk about that too much. We have an offline first client. This is the thing I told you about, like having the ability to use your application locally and synchronize automatically. This is a client that we have which leverages the IndexedDB on the browser. And our colleague Nico is a really good React developer, and he is working on the web UI. So this is the example. Like this is new, but the idea of the UI, it's in contrary to Django, like where your UI relies on the same server as your API. This is completely uncoupled. So with the same, because everything is done in front end in JavaScript. So the web UI can be deployed on GitHub pages, which is the case. Like it's deployed on GitHub pages, And then on the login form, you say, I want to administrate this server, and it's going to use the HTTP API to administrate the server. So it's a very nice way to have one simple deployment and several instances. One simple web UI deployment and administrate several instances. And hosting on GitHub pages is nice like this. What can I say? Yeah, so here you can define your JSON schemas, and it's gonna generate the forms, and you can administrate your data. You can do a small demo if you want after. And at Mozilla, we run Kinto at this address. It's a bit long, but we are kind of proud of it. It's in production right now. It is used to distribute some settings to all the Firefox browsers. So there are like 350 millions of browsers that pull this API to check the certificates revocation list. So basically, you know, this HTTPS relies on certificates, and those certificates sometimes are malicious, sometimes they are revocated. It means that they are replaced by new ones, or stronger ones, or maybe there are some problems with those certificates. And we want the Firefox browsers to be updated as soon as possible with the new SSL stuff. So that's what we use it for. We use it on Firefox for Android also, which is called Fennec. And in order to reduce the Android APK, you know, the APK is the format of Android applications. To make it smaller, when people install Firefox on Android, they don't ship big files like fonts, hyphenation dictionaries and stuff. They ship a very small APK, and then it uses Kinto to synchronize the assets, like the extra files. We use it also for experiments like A/B testing. So you try a new feature and you say, I want to give that feature to 10% of our user, and so it uses Kinto to check the new experiments and take the proportion of the population that you want to target with your experiment. And something that takes us lots of energy right now is that it's the web extensions. It's an API, and the idea is to allow any web extension to store data in the cloud. So we want to use Kinto because we want, contrary to Chrome, for example, which synchronizes everything to Google servers, we want to be able to say, okay, I have my own Kinto server, or my university has its own Kinto server. Let's remove it. I want my data to be stored there, and it's transparent for the web extension developer, but for the user, the data is kept under control. Some applications were made. So this one I did it this summer. It's small. You can create a form that just say, okay, how was your day, or did you like the food at that restaurant? And it would just show a screen with 3 smileys. You choose, and then at the end you can see some graphs. I think at Skyscanner you have that on the door. I saw that already. And I saw that at Decathlon. They have that on the cashier. And I was like, oh, but could have made money with it. But yeah, simple one. I wanted to do it because I wanted to use Redux, Saga. This is a collaborative map where you can see the pins moving and popping and disappearing. This is like an alternative to Google Keep, like a note-taking that are synchronized. This is a form builder, so it's hosted there as a service. You can define forms and ask questions, and it's like an alternative to Google Forms. basically. It relies on Kinto, JSON schema. This is picture sharing, but with geolocation. This is a scoreboard for a small game. This is a task list that are synchronized between families. Like it's called Rutina. It allows you to have like a recurring task, like changing the bed sheets, stuff that you forget to do when you are a programmer. And this is cool because this was shown. This is an idea that was shown by Javi. He came here in November and told us about Telegram wall project, and he told us about all the mechanism he has done for his boat to send some data to some wall. So when I came back, I said, okay, I'm going to do the same project, but I will replace the whole thing in the middle with Kinto. So I had just to write the Telegram bot, and there is a library for that, and the front-end page. And there was a farewell party at the co-working space I go to. And we did that, and it was very cool because we had a big screen. You could send some pictures to the Telegram bot, and they would show up. So it made lots of selfies, and it was fun. It was really fun. I'm planning to use it as for a wedding also. So the idea is from Xavi. The thing is he re-implemented the mechanism that we already have in Kinto. Okay, guys, I'm done with the product selling, and we'll now talk about Python and Pyramid. Is everything clear? Do I speak too fast?
It's okay.
It's okay. I didn't check the time. I'm doing good.
All of us have like 10 minutes, so.
Okay.
15.
Okay. I'll try.
10 minutes so far.
Okay, so I'll try to go fast, but remain clear. What we really like about Pyramid is that you pay for what you eat. You don't get 8 megabytes egg, and if you don't use what's available. Pyramid has a very long history, and the API, the API is very stable. Like you don't have to upgrade; it doesn't break. Like it's very, very, very stable. The patterns are good, even though sometimes they are a bit strong, but they are really good. And what really made us choose Pyramid is the flexibility and extensibility. I will go on that. That's what I want to show you now is the way the flexibility and extensibility is made in Pyramid. So a Pyramid web app can be done like that. Like it's a simple entry point. Like you have a main, you instantiate a configurator, you initialize your application using that config object, and you return a WSGI app. For example, if you have micro WSGI, or I think Django now uses those WSGI files, it's the same. It's like you import your entry point, you read some initialization, some ini files, and you pass the configuration values to your entry point. So this is the skeleton of an application in Pyramid. That WSGI file, you can run it with many tools. Micro WSGI is one of them. Well, Unicorn, whatever you like. So everything I'm going to show right now happens here, using that config object that I obtained from here. In Pyramid, the initialization is explicit. So there is no magic or less magic. It's reproducible and testable. Everything goes explicitly. So for example, if you want to add a view, you add a root, and then you say, I will map that callable a view is just a function that receives the request as a parameter. So a view is nothing more than a function that receives the request as a parameter. And then you map this function to that root. Why is there two steps? The idea is that you can have one view for the get, another view for post, another view for put, whatever, or another view for anonymous, a view for authenticated. So here you pass some predicates. Here you could do here comma method equal get, and this view would only be called with the get verb. Of course, there is this shortcut using decorators, so you can do all in once, basically. The configuration, as I said, is like it's a project backbone. So you do everything from this config object. The source code of Pyramid is almost only this object configuration. So you can add views, you can enable authentication policy, you can enable an authorization policy. Then you can listen to some events. I'll show you after that. You can have custom response render, response adapter to add some headers and stuff. So that's it. That's pretty powerful because it's very simple. And extensibility comes, for example, with the include method. You can include any package via the config.includes, or you can also have it included via the settings. So this is in the ini file. You put pyramid.includes, and this is going to be included. You can use that to modularize your application. Like, for example, if you have some optional view sets, a little bit like the blueprints of Flask, if you know Flask. You can have like optional event subscribers, and this include method allows you to cut your application into pieces and make it pluggable. A plugin or an add-on, it's just a simple Python module with a simple function include me that receives the config object. So you see, it's very, very simple. So that means you can have like a module that defines a new response renderer, for example, and is going to be included, and you can have a way to render responses in a new format than what you have by default. Contrary to some Django application, there is no import side effect, like everything is made explicitly, and you get a plugin system out of the box. This awesome Pyramid page lists every module, every plugins, everything. There is a Pyramid debug toolbar. You find classic stuff. As I said before, the application settings we keep them in ini files, and there is again no sorcery or black magic at execution time. I worked a lot with Django, and I have seen horrors. Doesn't mean it does. It's not a problem of Django. It's a problem that the way you use the fact that the settings files are Python files. Settings are settings. They should not execute code. So that's why we keep ini flat files. Same for Sphinx, documentation tool. You can see some crazy stuff in the conf.py in some projects. And it's op friendly because when your ops use stuff like Puppet or Chef, they are really happy if you tell them your configuration is an ini file, because they don't want to bother about 4-space indentation in settings files, for example. You can load any Python module from the settings. So for example, you can define a cache backend setting and then load it using the config.maybe.it, and the module name, and then you obtain the pattern module and instantiate what you need. So that's also a very easy pattern to have some pluggable parts of your system. In Pyramid, you have the notion of interface. So, for example, you define an interface, you implement a class, and you say, okay, I will register that class, that instance, to be the implementation of that interface. And then other parts of the code can query the registry and say, give me the component in charge, the service in charge of that interface, and you obtain the instance. That's also a pattern to have pluggable components in your application. And basically, you can hook everywhere. So you can have, like as I said, powerful root views mapping depending on verbs, user IDs, anything that comes in. Everything that's part of the request can become a distinguisher for the view that is mapped to the URL. You have events, you have callbacks, you have twins, which are like the Django middlewares, something that comes in and something that comes out. That's why they're called twins. Adapters, renderers, and the pyramid stuff. I'm saying stuff a lot, but sorry. The pyramid internals are can be overridden with the interface mechanism I was talking about. Event subscriber is very simple. You define a small object, very small object, with some payload, with some attribute, and then from a view, you instantiate an event. Here it's very stupid, and then you notify the event. So it's very simple. So that's when your view is executed, this event is sent. And then using this config object I was talking about, you can add a subscriber and say, okay, I want you to call me this method when this event is triggered. And then here you can do whatever you want. You receive an event, you have the event payload I was using, the request. I change the request headers, for example, and I do stuff. This is very, very simple. You can also raise HTTP exceptions, like for example, if someone reaches the storage quota, or do what you want. The only thing, it's so simple that it's executed synchronously. Can be useful for transaction notions, but for long tasks, you have to use a job queue. Should I talk about that? Yeah, I can quickly. Pyramid allows you also to define your own config methods. So here, for example, I defined something that is called add API capability that received an identifier and a description, and I store that in the registry, which is like a singleton. And I say, add this new directive, add API capability, and use that method to do it. And now I have a new method on the config object, which is add API capability. And I can use it, for example, for my plugins to declare themselves as enabled on the API. So I say, when I implement a plugin, I say, this plugin adds a new API capability called history, and the description is that. And then I can have a view that exposes every plugins enabled on the API using this singleton I was talking about before. So it allows you to create your own domain-specific method, which makes Pyramid the framework for frameworks. Like, you can develop your own framework on top of Pyramid. It's very important. For example, if you want all your project to respect good HTTP practices, you can have a small set of helpers, and your team developers would use those helpers, and they will share the good practices in every API of your company, for example. Testing is very easy using web tests. I forgot to import it. Basically, you give some settings, you take the main entry as we had before, and you instantiate an app, and then you can have like self-app.get, hello, and obtain the response. It's very, very easy. Doesn't have any magic. It's flat and simple. And this is the last part of my presentation. This is not related to Pyramid, but I thought it was interesting to mention, because maybe you guys are going to say, ah, no, Pyramid, I don't want to use it. So at least you would keep that part. This is two patterns. One is called composition, and the other one is called inheritance. And that's very interesting because, for example, Django uses inheritance a lot, and Pyramid uses composition. So inheritance in Django, it means you will have mixins, you would inherit the models, you would inherit the admin model, you would inherit classes, and define what's missing or some options. So with inheritance, you change the behavior of the class, but to substitute the original one, you have to take a hook before it is instantiated. So that's also why there is not anymore, but there was so much magic in Django. It's because before it was going through every apps and importing the models, I think, models files, and doing some introspection there. Now in the last version, I think it was 1.8 in Django, something like that, you have a true initialization sequence that makes this more explicit. But this is a problem with inheritance, is that you cannot substitute easily if you cannot control the place where it is instantiated. But with composition, instead of overriding the main class, you have like a delegate component, or you have another component, and this component can be substituted after the main one is instantiated. It's very stupid, but it changes a lot the way you can hook into the framework, because frameworks are really good, but you don't want to fight the framework. Yeah, I mean, they give you good practice and good boilerplates, but you shouldn't fight them. So composition gives you readability, flexibility, single responsibility. You can compose several unrelated packages, and also avoid multiple inheritance, which is a bad pattern. Everybody agrees on that, because you don't know who is actually executing what's going on, and it's really hard to track. The downside of Pyramid is that Pyramid is not the latest cool stuff on the street. Some projects in the ecosystem are not active, but if you open an issue and say, are you still maintaining that? They say, yeah, but there's no bug and it works. So usually, yeah, some projects haven't changed for a long time, but it just works. Also because the API of Pyramid is very stable. One of my critics, like personal ones, is like the documentation lacks real-life examples. It's also really easy to couple everything to the request object, and the built-in authentication policy are really not intuitive to use. That's it. I hope I was not too fast. If you have questions, I'm really open to anything. There is this website, Try Pyramid, and this is the documentation of Kinto. You have IRC channels, Slack, mailing list, and everything. And if you want to troll, you can reach me. So, yeah, if you have questions.
Okay, we have time for a couple of questions.
I do have one.
Okay.
Well, how would you define the place for Pyramid in the web frameworks in Python? I mean, we know when to use Django, when to use Flask, when to use Twisted, but Pyramid, what is its place in all this environment?
I can tell you about Pyramid, for example, at Mozilla is mainly used for API stuff, API services. APIs, it's really good for APIs. As David said, it's really bad to re-implement Django using Pyramid. Django is good for what it is, and Pyramid also is good for what it is. I would say it's in between Flask and Django. So the problem with micro frameworks like Flask, even though Flask, now that there are the blueprints, it's good, it's very good. But like for example Bottle and stuff like that, it's nice to start, but if you have a big team with lots of contributors, lots of co-workers, it's gonna become a mess because there is no rails and you can do what you want. So if everybody is very experimented, it's gonna go fine. But it's not usually the case. And even though with time, people like things get dirty. And Pyramid gives you a structure that you can keep with when your project grows. But it doesn't do administration panel as good as Django does, for example. So if you have, I don't know what, the thing also, it depends what you're looking for. Like Pyramid is very efficient. It's a framework for purists. It's very pure. It's very clean. But if you want to hire some Pyramid developers, you won't find any. Because
but there were places for that. I saw it.
Sorry?
There are a lot of vacancies. Well, I saw a couple here in Barcelona for Pyramid.
Really?
I was surprised, like,
interesting.
Pyramid, really?
Yeah. The thing, like, I've been a Django developer for many years, and I do Pyramid at Mozilla because it's one of the tools that are used for APIs, and it's very, very powerful and very nice to work with. But it's not like kikulol, click, and I get my project like Django. You have to know what you're doing. You have to go into the design of your API to do the components clearly. Same for Flask actually. Like it requires some engineering good practices, but it's very intuitive as well. So it's an in-between between Bottle and Django, and it's probably closer than Flask and the rest. And Flask also evolved a lot. Flask started as a quick hack and ended up as a framework, but in the beginning it was just like. So yeah, now it's very similar to Flask. Sorry for that long answer.
No, thank you.
More questions? Pues, aplauso.